Hello, everybody. Right now we are going to be looking at Chapter 6 and everything you need to know about it. Now, this actually does have a little bit of 10.6, but we're not going to talk about that, so let's get right into it. Starting off with the Law of Sines versus the Law of Cosines. So these both sound very familiar. They sound very similar, but they're actually used for very different cases in a triangle. So if you have angle, angle, side, angle, or side, angle, you will have the law of sines. Now, all this makes sense. Angle, angle, side, angle, side, angle. The numbers in the middle represent how many triangles you can have. We'll come back to side, angle. It's very special. We'll come back to that in a bit. Likewise, if you have side, angle, side, or side, using the law of cosines. Same thing. So side, angle, side. Both these give you one triangle. So let's have some examples. So we have that angle A equals 87 degrees, angle B equals 33 degrees, and side C equals 10 degrees. So this is a side angle. So this is an angle side angle, meaning that we're going to be using the sine equations. And whenever you have sine, you're going to use this one overarching equation of all. So it's just sine A over side A equals sine B over side B equals sine C over side C. And for future reference, a capital letter is an angle, a lowercase letter is a side. So for this equation to work, you have to have one of the letters has to have both an angle and a side, which right now we don't have, meaning we need to solve for either a side or an angle. And right now, since we have two angles, we can use our cheeky little angle trick that we know of, where we take 180 minus our two angles to get our third angle, in this case C equals 60 degrees. Now that we have at least four of the elements, I'll be calling them, now we can use our equation to solve. So plug everything in. We have sine 87, which is angle A over side A. We don't know that yet. Equals sine 33, which is angle B over side B. Again, we don't know that. Then you have sine 60, our newly discovered C angle, over 10. We actually have a side for 10. So basically, we just go one at a time. We're going to start with B. You cross multiply. So in this one, just divide by sine 60, and you get that B equals 6.29 inches. We do the same thing for side A. Cross multiply, divide by sine 60, and we get that A equals 11.531 inches. And there you go, you're done. Looking at this one is that angle A is 87 degrees, side B is 3 inches, and side C is 7 inches. So this one is side angle side, meaning we're going to be using cosine instead of sine. And when you're using cosine, we're going to be using these three equations. Now, these two equations are actually interchangeable. The value that is out here in the equation is going to be over here, except capital for the angle. And whatever value isn't out here is right in here and then in here. Just remember, it's out here, it's square, and then you're adding squares, but multiplying just normal. So we're going to get started by solving for side A, because it will make solving for angles a lot easier. So we plug everything in, we get A squared equals 3 squared plus 7 squared minus 2 times 3 times 7 to the cosine of 87. So now we simplify down. A squared equals 9 plus 49 minus 42. We're going to take out the cosine. So you get 9 plus 49 minus 2.198, ... Hold the long number in your calculator. Excuse me. So Put all those together, you get 55.801 dot dot dot. Again, hold that long number, take the square root, and you get that A equals 7.47 inches. Now you have all three sides, so solving will be a lot easier, solving for the angles. So now we're going to solve for angle B down here. You have 3 squared equals 7.47 squared plus 7 squared minus 2, 7.47 times 7 to the cosine of B. We're solving for an angle. So this one, you simplify it down, you get 9 equals 59.800, hold the long number, plus 49 minus 104.58 to the cosine of B. This is all technically one value. So we're gonna put in parentheses just so we know not to touch it. Then we're gonna take out. So then we're gonna add 49. We're gonna combine like terms. So you get this full 104.8009. Subtract that from both sides to get negative 95.8009. And we're going to divide the negative 104.58. Now that values by itself. To get 0.916, dot dot dot, hold the long number, take the inverse cosine, and we get that B equals 26.644 degrees. Now that we have two angles, we can use our angle formula, which I'm going to show you a long way. You plug it in, combine it in the parentheses to get 69.356 degrees. Now this is the special case. The ambiguous case is called. So every case we discuss will give you one triangle except for side-side angle. We'll give you between 0 and 2 triangles. And the secret is this very special digit right here, H. So if M right here in row F is C is greater than B, you'll only have one triangle. But if M is less than N, you will have to solve for this magical H value. Now, if H is greater than M, you're not going to have any triangles. It's the easiest one of all. If H is equal to M, you're only going to have one triangle, and it's going to be this right triangle, so it's going to be very easy to solve. Now, the hardest case is if H is less than M. I mean, you're going to have two triangles here. This is actually very difficult. So let's analyze this. So as you can probably tell, there's a lot of numbers going on here. This is going to be a hard one. But not too hard, because it's actually very similar to what you do. You just kind of do it twice. So to start off, we need to solve for the magical H value you actually can't see right now. That's my bad. Just imagine there's a line going from here to here with an H in the middle. And there you go. So if we look at it that way, we actually have a small right triangle. So if we want to solve for H, it's the opposite of our angle 45, which means 6 is the hypotenuse. So we can actually do 6 sine 45 equals H. When we do that, we get that H equals 4.243, which that is less than our C value of 5, meaning we have two triangles. So we're going to start off by solving for our final. We're going to solve for our first angle B. Remember, this is a sine equation, so we get to use our sine overarching equation. Plug everything in, cross multiply. This time's a little different because we're solving for an angle and not for a side. So take that sine 4.242, hold that value, divide by 5 on both sides. Again, hold this long number, and take the inverse sine, and you get that B equals 58.052 degrees. From there, we can use our angle formula to get 76.948 degrees. With that information, we can now start solving for A. Well, A1. So it's the same equation here. Sine 45 over 5 equals sine 76.948 over A1. Cross multiply, you get that. Divide both sides by sine 45, and you get that A equals 6.888 inches. Now everybody, take a deep breath in and out. because there's a whole other triangle to deal with. But calm down, calm down, calm down. It's not actually that bad. For example, the three values that we discussed that were given, those values stay exactly the same. And you want to know what you can do? If you take 180 minus your original B angle, this angle right here, take 180 minus that, you actually get your B2. Because if you think about it, if you look at it the correct way, what's actually happening here, if this is a real life application, this right here would actually be a swinging hinge off of, think of a crane. This is the ground, this is the crane length, and this is the swing length. They're not actually touching the ground. So what actually happens is this. So what actually happens is this will swing over to over here somewhere, which means you actually have two, which is where the second triangle comes from. So we have this angle over here, which becomes this angle over here. And with the way math works out, this angle has to be equal to this angle because they're on the same plane. Yeah, I'm getting way too complicated with this. Let's just move on and get to the actual math of this. So starting off, we're going to use our cheeky angle formula. Get us down, they find out that A2 is 13.052 degrees. And then the same thing we did before, sine 45 over 5 equals sine 13.052 over A2. Cross multiply, divide both sides by sine 45, and you get 1.597 inches to complete this very long, but quite simple, actually, problem solve. Now, I never mentioned this, if you use a separate equation with side equals side, you can actually calculate the area of a triangle. You guys ready? I have a very totally realistic, real life way to use this. So let's say you wanted to go to the Mall of America, because who doesn't want to go there? I've been there twice. It's great. So you had a great time, but you weren't impressed with the rides. Remember, it's indoors. You can't have no rides there. And you want some more Disney in your life. So your solution, you drive to California and go to Disneyland. So the good news, you got that more Disney, but bad news, you only went to Disneyland. You didn't actually get the full experience. Solution, drive across the country, go to Florida, and go to Disney World. So you finally got all that you want. You got that joy. You got the fun rides. And then you realize you left some of your luggage at the Mall of America. So you call the security, and sure enough, they have it. So you drive back to Minnesota and get your luggage. Now it just hit you. So you just realize that you did all of that. You traveled the country just because you wanted more. So your friends are going to call you crazy if you say that. So what you're going to do is you're going to actually use the math that you learned in high school. I told you it would have a use, and you're going to calculate the area of the triangle you just made to say you have a reason. Because that's totally realistic, right? Okay, it's not realistic, but I actually got these numbers, so here we go. So point A is the Mall of America, point B is Disneyland, and point C is Disney World. So we have side, 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 but we're solving the area, not the angles. So we're going to have to use a little bit of cosine magic to get our A angle. But you can do any of these. I just chose A because I like A. So take our equation, plug everything in, and so you got 2,501 squared equals 1,913 squared plus 1,549 squared times minus 2 times 1,913 times 1,549 times cosine of A. Hold on with me. These numbers are going to get big. So you have 6,255,001 equals 3,659,569 plus 2,399,401 minus 5,926,474 to the cosine of A. Combine like terms, and then combine these two like terms together. Subtract that out to get that over here, to get that 1 to get 196,031 equals negative 5,926,474 cosine of A. Subtract that 5 million, we get negative 0.33, hold that number. Cosine of A, take the inverse cosine, we get that A is 91.896 degrees. Wow. Now, we have to take for granted, of course, it's not this perfect. Of course, the roads are squiggly, and Google Maps takes into account the construction and traffic patterns. So it's not a perfect triangle, but it's something, right? It's close enough. It's the best thing I could find. So now that we have this, we're going to use actually a pretty simple equation to find our area. And it's this, again, interchangeable. So whatever value, so you have the angles out here. Whatever value you don't have out here is right here, except it's sides. So you just plug everything in, and we get, hold on, folks, 1,480,807.356 square miles. Holy cow, that's a lot of land that we just covered there. All because we wanted more. I'm very greedy. Right, so we're done with that. So now it's time to do some story times with parametric equations. Now these are actually in 10.6, but we don't talk about that. So let's say it takes me 4 seconds to walk from point A, which is 5.6, to point B, which is 13.10. So we're going to develop those equations. So then we're going to calculate where I am 3 seconds after leaving point A, traveling towards point B. And then we're assume that I see somebody who I haven't seen in a very long time down here. So once we get to that 3 second mark, we're just gonna cut a full right turn and take 2 seconds to walk to this point, because I'm a crazy person. So we have our graph over here. So we're just gonna get to work. So there's two equations that are gonna make our life insanely easier for this. First of all, these are the actual parametric formulas. So x, we have x0 plus at, and then y0 plus bt. So x0 and y0 are the horizontal and vertical starting positions. A and b is, well, it's hard to explain. This is A and B. So this is actually supposed to be a t. That's my mistake. Supposed to be time. So basically this is the finishing point minus the starting point divided by time. But this is wrong. This is supposed to be a t and not a 2. Just ignore it. So let's apply it to some of our equations. So the first problem was to develop the parametric equations talking from here to here in 4 seconds. So let's start us off. So x0 is 5 because we started at 5. So A, we take 13 minus 5, which is 8. Divide that by 4 because that's how much time it took. And we get 2t. So the same thing for y. This time for y we started at 6 though. And then we take 10 minus 6, which is 4. So divide that by 4, we get 1t. So first problem solved. So the second problem, we want to calculate where it was 3 seconds after leaving point A. So we just plug in 3 for both of the equations. So we start with 5 plus 2 times 3. 2 times 3 is 6. We get 11. That's an 11, I swear. And then we take 6 plus 1, plug in 3. So 6 plus 3 is 9. So we take our 11 and 9 and plug it in to a point. So this point is approximately right here on our graph. I didn't draw it though. So now, to solve our other part of the equation, we just got to do the same thing we did for the start, but with this point and this point, with a time of 2 seconds. So for x, we started at 11 plus 0, because 11 minus 11 is 0. Divided by 2, well, we're already at 0. So, yeah. For y, it's 9, because we started up here. Then we took 2 minus 9, which is negative 7. Divide that by 2, we get negative 3.5t. Yeah, because I like ugly numbers. I don't, actually. That's a joke. So with that, congratulations. You made it through Chapter 6 and a little bit of 10.6. But again, we don't talk about that.